You are watching a Target 1.3 retest film. In this film, we are going to do a couple of the problems that you will find in your white retest packet. Remember, you need to finish that whole packet in order to do any kind of retesting. You also need to bring it with you to the retest day to make sure that we know that you have it done. Okay, Target 1.3 states that I can represent real-world situations as linear programming problems and demonstrate an understanding of how to find reasonable solutions. So it starts out with doing some systems of inequalities and finding those solutions. I picked a few problems from your packet. We're going to do number 1 and number 7. And then it follows with an actual linear programming problem where you have to set it up. Okay, finishing it is also another objective too. So we're going to go through those problems. So let's start with number 1. Number 1 says to sketch a solution of each of these, and notice these are both in slope-intercept form. So we're going to use slope and intercept to graph them. Okay, so let's do the first one. The slope or the y-intercept is -7. So here's y -7. And then the slope is -1. -1 over 1 means down 1, but then remember, it's always to the right. Too many people right now are going down and then left. They see negative and they think left. But it's down, that's the negative, but always to the right. So down 1, right 1, down 1, right 1, down 1, right 1. So there is our line. This is a greater than or equal to, so it's going to be a solid line. And then we'll figure out which way to shade. Alright, so shading this one, we're going to test out a point. 0, 0 is usually the easiest one to test. And remember 0, 0 is an x and a y. So 0 is greater than or equal to -0 minus 7. 0 is greater than or equal to -7. That is true. So that means we shade on this side. Now I'm going to use a couple different colors so you can see what our final answer is going to look like. The second one, we're going to start at +6. That's right here. And the slope says up 9, or 9/4, which means up 9, and then right 4. Now notice we can't go up 9, so we could kind of, I suppose, fake it a little bit and draw 5 more lines and then over 4. But remember, that point is going to be up here somewhere, which means if you draw that line, that also means down 9 spots and left. So you can also go the opposite of these, down and left. Okay, on the previous one, that would have been up and to the right. Notice it goes up and right too. Alright, so this one, down 9 spots. So 6, down 9, and then left 4 takes me to here. And then down 9 takes me off the graph one more time. So less than or equal to means a solid red line. Draw a solid red line, and then I will move it up. Alright, so we have to test this one too to make sure that we know which side to shade. I'm also going to do 0, 0 in the second equation because it's not on the line. So I have 0 is less than or equal to 9/4 times 0 plus 6. That means 0 is less than or equal to 6. This is also true. So I'm going to shade over the 0, 0. Alright, now remember, if you get a false reading here, you shade the other side of the line away from 0, 0, and see what happens then. So our solution for all of these problems is to figure out which quadrant gets shaded a couple of times. So we have 4 quadrants here. We got one here, we got one here, we got one here, we got one here. So we want to know which one of those 4 places got shaded twice. So this one right here got shaded no times. So that one's out. This one right here gets shaded just by the blue, so that doesn't work. This one right here gets shaded just by the red, so that one doesn't work either. Whereas this one here got shaded twice, red and blue. So that is the one that works. That is our solution. We'll shade that one in a little darker, and there's your solution. Okay. Again, if you don't remember how to graph using slope and intercept or how to shade and get an answer here, rewind the film and watch it again. We'll do number 7 now. I'm going to use blue and red again. These are in standard form, so we're going to do we're going to do an XY table with intercepts. So 0 for x. That means y is equal to -4. That's right here. And 0 for y gives me, let's see, 2x. I'm going to divide by 2. I get x equals 6. That is right here. This is a less than or equal to, so it's a solid line again. And I'll draw kind of long and then move it up here. And let's figure out which way to shade. If I plug 0, 0 in, I get 0. Oop. Sorry. Okay, if I plug 0, 0 in, I get 2 times 0 minus 3 times 0. It's less than or equal to 12, so 0 is less than or equal to 12. That is true. So here's 0, 0. I need to shade all of that stuff on that side of the line. Let's do the other one. 0, 0 table again. So 0 for x, 5 times 0 plus y equals 10. That means y is 10. And 0, 10 is right here. And then 0 in for y. 5x plus 0 equals 10. Divide by 5, I have x is 2. There's the other point. This one is just a greater than, so we're going to use a dashed line. Ooh, did a couple lines up there. Sorry about that. I'll get rid of that one. Okay, and then we'll figure out where to shade. I'm going to plug 0, 0 in again. 5 times 0 plus 0 is greater than 10. I get 0 is greater than 10. That is false. So false means that the 0, 0 doesn't work. Everything on the other side does. And we'll talk about the quadrants again. So this quadrant right here got shaded no times. Nothing was shaded there, so we're not going to use it. This quadrant here was just shaded by the blue, so we're going to erase everything in there. Okay, this area here is just shaded by the red, so that's not a solution to both of them. And this area here was shaded by both. So it's a solution. All those points are a solution to both equations, and therefore the solution to the system. Now, I'm doing erasing some that touch the red line. Remember, the red line is dashed. That means nothing on it can work in both equations. All right, again, if you don't remember either of those, go back and rewatch it. If you still need help, go see your teacher before or after school. Number 15 on this slide, we're going to do this one. We're going to define the variables, write an objective equation, and then write the system of constraints. So let's look at this problem. It says a farmer has 320 acres of farmland. They're going to plant 2 crops, corn and soybeans. Okay, and ultimately the question that you want to ask yourself is, what are they asking you to do? Well, they're asking you to maximize profit. And what do we know about profit? Let's see, it looks like there's a profit number, there's a profit number, and that has to do with soybeans and corn. So that's what we're going to use. C is the number of bushels of corn, and S is the number of bushels of soybeans. Okay, and from those we can go ahead and write the profit equation right away. Corn is $60 per bushel, and looks like soybeans is $90 per bushel. For an acre. All right, so now we need to talk about the constraints. So the first constraint that I see is right here. 320 acres of farmland. Can't go over 320 acres. Just got 320 acres. And all that means is that the number of, oh my goodness, sorry about that, corn. The number of acres of corn and the number of acres of soybeans, and when you add them up, they have to be less than or equal to 320 acres. Okay, and then it goes into each corn, her expenses are 50 acres and 100 acres, $50 and $100 for soybeans. And let's see, corn requires storage of 100 bushels, soybeans 40 bushels, and then down here it tells us the space available and the money available. So since C and S are our variables, we're going to use those on top, C and S, and a total. So the total that we have, let's see, storage space, so this must be space, and this must be money then. Those are our two limitations. We only have 19,200 for space, and we only have 20,000 for storage, or for money. So now let's look at corn. Let's see, the first sentence says, for each acre of corn planted, her expenses are $50. So $50 for corn. And then it says her expenses are $100 for soybeans. So that has to go on the money row. This also says that 100 bushels of storage for an acre of corn. And let's see, soybeans only require 40 bushels of storage for an acre. Okay, so we have these labeled. Now all we need to do is go from left to right. 100C plus 40S, and that's got to be less than or equal to 19,200. Now remember, that's a storage space, that's a maximum, that's why it's less than or equal to. Okay, and then 50 C's plus 100 S's have to be less than or equal to $20,000. Can't spend more than $20,000. And there you have it. We have the variables defined, we have the objective equation, notice it's an equation, and we also have the constraints. Okay, again, rewind and watch that again if you need to. We're going to move on to number 21. And it says in number 15, which we just completed, consider the graph below to finish the problem. Do not forget to write your answer in words. And it says the objective equation is P equals 60C plus 90S. So it's actually graphed for you, and we're going to keep the variables in the correct order. So C is our X axis, and S is our Y axis. And this area that's shaded is called the feasible region. That means with all the constraints we have, every one of those points in that gray area work. So what we need to do is pick out the one that gives us the maximum profit. Okay, we're looking for max profit. That's what it says in the problem. Here's the problem. Let's see, maximize her profit. So let's look at this one. Now, what we did in class was we decided, hey, let's take that profit equation, make a line out of it, move it across the graph, and we see that it's always going to hit one of the vertices last. So if we test the vertices, that should yield a maximum amount of money. So the vertices of this shaded region are right here in blue. This one is 0, 0. This one is, looks like 190, 0. It might be 192. This one is, let's see, 140, 130, and this one is 0 and 200. Okay, now we're going to use those points, those coordinates, and test them in the profit equation. So remember, the profit equation is 60C plus 90S, and we have 0 and 0. 192 and 0, 140, 130, and 0, 200. Okay, plugging them in, remember that this is a C, that's the x-axis, and the S is the y-axis. So therefore, we have x is the C variable. So the first one is a C variable. So this one, the profit is 60 times 0 plus 90 times 0, and I get $0. I don't know about you, but I probably would plant more than 0. For the second one, it is 60 times 192 plus 90 times 0, and for that one I get, in the calculator, $11,520. For the third one, it's 60 times 140 plus 90 times 130, and for that one on the calculator I get $20,100. And the last one, 60 times 0 plus 90 times 200, and for that one I get $18,000. Now we want the maximum profit, which would be this one. So when we write our sentence, let's make sure that we put that in context. So let's go back to the problem real quick. It says a farmer has. So a farmer is going to plant crops. So we should write the farmer should plant 140 acres of corn and 130 acres of soybeans to maximize his profit of $20,100. There you go. All right, feel free and rewatch that whole piece. Go back and watch the whole thing if you want to, but make sure that you are able to do all of those problems in the worksheet. When you finish it, you will be allowed to retest. If you need any more help, go in and get some help from your teacher.